The manufacturer provides a device that is FM approved as non-incendive, C learn, DI V2, GPA, B, C, D, T4. This device is enclosed in a non-explosion proof, non-purged enclosure and includes relay output contacts. It requires a power supply input of 24 to 253 volts alternating current or direct current. NEC 501.10b4 states that in Class 1, Division 2 locations, equipment must be listed for Class 1, Division 2 locations. The device's FM approval for Class 1, Division 2 meets this requirement. NEC 501.105b requires enclosed switches, circuit breakers, motor controllers, and fuses to have a means for attachment to the enclosure for grounding. The warning label on the device specifying bonding meets this requirement. The device includes a warning label stating explosion hazard: do not disconnect equipment unless power has been switched off or the area is known to be non-hazardous. This means the device must not be disconnected in a hazardous location unless the power is off or the area is known to be non-hazardous. The device requires a power supply input of 24 to 253 volts alternating current or direct current. The installation must ensure the power supply voltage is within this range. The device has a warning label stating bonding between conduit is not automatic and must be provided as part of the installation. See installation instructions. This means proper bonding between conduits is essential for electrical continuity and to prevent static charge accumulation. Firstly, the device must be FM approved for Class 1, Division 2 locations. Secondly, installation must be according to the manufacturer's instructions, including proper bonding. Thirdly, the device must be used with a power supply voltage within the specified range of 24 to 253 volts alternating current or direct current. Fourthly, it must be operated in accordance with the warning labels regarding power disconnection and hazardous locations. To further clarify the requirements for compliance with NEC 501.10b4, the equipment, specifically the analyzer or transmitter in its non-explosion-proof enclosure, must be tested and certified by a nationally recognized testing laboratory, like FM approvals, for use in Class 1, Division 2, Groups A, B, C, and D hazardous locations. This listing ensures that the equipment will not cause ignition of flammable gases or vapors that may be present in these locations under normal operating conditions. This requirement addresses the risk of sparks or hot surfaces igniting the hazardous atmosphere. For NEC 501.105, the requirement for grounding means ensuring a low impedance path to ground for fault currents. The bonding mentioned in the warning label pertains to creating this low impedance path. This is typically achieved by connecting all metallic components of the electrical system, including conduit, enclosures, and equipment frames, together into a grounding electrode system. The purpose of this bonding is to minimize the potential for voltage differences between conductive parts, which could cause a spark during a fault condition, and to facilitate the operation of overcurrent protection devices, such as circuit breakers or fuses, to quickly clear the fault. The additional warning label emphasizing that bonding between conduit is not automatic highlights a critical point often overlooked. Standard conduit connections may not provide adequate electrical bonding due to paint, corrosion, or loose fittings. Therefore, the installation instructions will likely specify the use of bonding jumpers or other approved methods to ensure a reliable electrical connection between conduit sections. The installation instructions should also detail the acceptable methods for connecting the equipment to the grounding system, including the size and type of grounding conductors to be used. The fact that the equipment can accept a wide range of voltage inputs from 24 to 253 volts alternating current or direct current provides flexibility in its application. However, it also places a responsibility on the installer to ensure that the voltage supplied to the equipment is within the specified range and that the power source is properly rated and protected. This may involve the use of a step-down transformer or other voltage regulation device. The warning label regarding the explosion hazard when disconnecting equipment reinforces the importance of following proper lockout/tag-up procedures before performing any maintenance or repairs on the equipment. These procedures are designed to ensure that the equipment is de-energized and isolated from all potential energy sources before work begins, preventing accidental ignition of a hazardous atmosphere. It is crucial to understand that the FM approval for Class 1, Division 2 does not eliminate the need for proper installation and maintenance practices. The approval only indicates that the equipment has been designed and tested to minimize the risk of ignition under normal operating conditions. The installer and end user are still responsible for ensuring that the equipment is installed and operated in accordance with all applicable codes, standards, and manufacturer's instructions. In summary, providing an FM-approved device that complies with NEC 501.10b4 and 501.105 involves more than just the equipment itself. It also requires careful attention to installation practices, grounding and bonding, power supply considerations, and adherence to warning labels. By following these guidelines, manufacturers and installers can ensure the safe and reliable operation of electrical equipment in hazardous locations. The process for obtaining FM approval involves several key steps. Firstly, the manufacturer must submit the device to FM approvals for evaluation. This submission includes detailed design documentation, specifications, and test data. Secondly, FM approvals conducts a thorough review of the device's design to ensure it meets the relevant safety standards for Class 1, Division 2, Groups A, B, C, and D hazardous locations. This review includes an assessment of the device's construction, materials, and electrical components. Thirdly, FM approvals performs a series of tests on the device to verify its ability to operate safely in a hazardous environment. These tests may include thermal testing, electrical testing, and mechanical testing. Fourthly, if the device passes all of the tests and meets the requirements of the applicable standards, FM Approvals issues an approval certificate. This certificate authorizes the manufacturer to mark the device with the FM approved mark. Fifthly, FM Approvals conducts periodic audits of the manufacturer's production facility to ensure that the device continues to be manufactured in accordance with the approved design. The standards used by FM Approvals for evaluating equipment for Class 1, Division 2 locations are based on both national and international standards, including the National Electrical Code NEC and the International Electrotechnical Commission IEC standards. These standards specify the requirements for the design, construction, and testing of electrical equipment intended for use in hazardous locations. Key aspects covered by these standards include temperature ratings, enclosure protection, grounding and bonding, and intrinsic safety. The temperature rating, also known as the T code, indicates the maximum surface temperature of the device. This is critical because if the surface temperature exceeds the ignition temperature of the surrounding flammable gases or vapors, it could cause an explosion. Enclosure protection refers to the degree of protection provided by the device's enclosure against the ingress of dust, water, and other environmental contaminants. This is important because if these contaminants enter the enclosure, they could cause a short circuit or other electrical fault, which could lead to an ignition. Grounding and bonding are essential for minimizing the risk of electrical shock and for providing a low impedance path for fault currents. This helps to ensure that overcurrent protection devices, such as circuit breakers or fuses, will quickly clear the fault and prevent an explosion. Intrinsic safety is a protection technique that involves limiting the amount of energy available in the device's electrical circuits to a level that is too low to cause ignition, even under fault conditions. In the context of the warning label, the phrase explosion hazard "do not disconnect equipment unless power has been switched off or the area is known to be non-hazardous" is a standard warning used on equipment intended for use in hazardous locations. It emphasizes the importance of taking precautions to prevent the ignition of flammable gases or vapors when disconnecting the equipment. The reason for this warning is that where a circuit is broken, it can create a spark. If the equipment is located in a hazardous area, this spark could ignite the flammable gases or vapors, causing an explosion. To prevent this, the power must be switched off before disconnecting the equipment, or the area must be verified to be non-hazardous. The phrase bonding between conduit is not automatic and must be provided as part of the installation. SE installation instructions is another important warning that highlights the need for proper bonding. As previously mentioned, bonding is essential for providing a low impedance path for fault currents and for minimizing the potential for voltage differences between conductive parts. If the conduit is not properly bonded, it could become energized during a fault condition, which could create a shock hazard or cause a spark that could ignite the flammable gases or vapors. The installation instructions should provide detailed guidance on how to properly bond the conduit, including the size and type of bonding jumpers to be used and the proper torque for tightening the connections. In addition to the requirements specified in NEC 501.10b4 and 501.105 there may be other applicable requirements depending on the specific application and location. For example, if the equipment is installed in a corrosive environment, it may be necessary to use corrosion-resistant materials or to provide additional protection against corrosion. Or, if the equipment is installed in an area where it is subject to mechanical damage, it may be necessary to provide additional protection against impact. It is also important to consider the potential for static electricity buildup, especially in areas where flammable liquids or gases are being handled. Static electricity can be a source of ignition in hazardous locations, so it is important to take steps to minimize the risk of static discharge. This may involve grounding and bonding all conductive materials, using static dissipative materials, and controlling the humidity. In summary, providing an FM-approved device that complies with the requirements of the NEC for Class 1 Division 2 locations requires a comprehensive understanding of the applicable codes, standards, and manufacturer's instructions. It also requires careful attention to installation practices, grounding and bonding, power supply considerations, and adherence to warning labels. By following these guidelines, manufacturers and installers can ensure the safe and reliable operation of electrical equipment in hazardous locations. Remember to always consult with a qualified electrical engineer or other professional to ensure that the installation meets all applicable requirements. It is crucial to emphasize the importance of following the manufacturer's installation instructions precisely. These instructions are not just suggestions, they are specific requirements that must be met to ensure the safe and reliable operation of the equipment. The installation instructions will typically cover a wide range of topics, including mounting, wiring, grounding, bonding, and commissioning. They will also provide detailed information on the proper use of any accessories or components that are required for the installation. Failure to follow the installation instructions could void the FM approval and could also create a safety hazard. For example, if the equipment is not properly mounted, it could vibrate or become dislodged, which could damage the equipment or create a shock hazard. Or, if the wiring is not properly connected, it could cause a short circuit or other electrical fault, which could lead to an ignition. The installation instructions will also specify the required clearances around the equipment. These clearances are necessary to provide adequate ventilation and to prevent the buildup of heat, which could increase the risk of ignition. It is important to ensure that these clearances are maintained at all times. The installation instructions may also specify the type of conduit and fittings that must be used with the equipment. This is important because some types of conduit and fittings may not provide adequate protection against the ingress of flammable gases or vapors. Only approved conduit and fittings should be used. In addition to the manufacturer's installation instructions, it is also important to consult with the local authorities having jurisdiction AHJ to ensure that the installation complies with all applicable local codes and regulations. The AHJ may have additional requirements that are not covered in the manufacturer's installation instructions. It is always best to check with the AHJ before beginning any installation work. In conclusion, the successful implementation of an FM-approved device in a Class 1 Division 2 environment hinges on a multifaceted approach. This includes rigorous adherence to the manufacturer's installation instructions, compliance with all applicable codes and standards, and a thorough understanding of the potential hazards associated with the location. Proper bonding and grounding, appropriate wiring methods, and the use of approved components are all critical elements in ensuring the safety and reliability of the installation. Furthermore, ongoing maintenance and inspection are essential to identify and address any potential issues before they can lead to a hazardous situation. The device, having a wide voltage range of 24 to 253 volts alternating current or direct current, does not negate the fact that one must follow strict NEC guidelines. The non-explosion proof, non-purged enclosure does not impact the NEC, since it meets guidelines for Division 2 requirements. One must remember to follow the manufacturer's guidelines for installation as well as proper power requirements.